and welcome everyone. In this chapter, we will start OSPF. So, OSPF, Open Shortest Path First. Since OSPF is one of the open standard protocol, that's what it is, OSO, open. And then SPF is the algorithm, shortest path first itself is the algorithm. Okay. So we'll see the detailed information about the OSPF and later on we will see the demos as well. Let's go with the flow now. So let's get started. So OSPF, as we discussed, OSPF is one of the open standard protocol which is supported with every vendor devices. You can configure this in Cisco, Juniper, Barracuda, any of the vendor devices you can configure this OSPF. So it is also an link state protocol. Since we discussed in our previous lecture, we discussed about EIGRP, and EIGRP is one of the advanced distance vector protocol, but OSPF is the link state protocol that you have. It is a classless routing protocol. Classless routing protocol is about it carries the subnet mask in the routing information, in the routing updates, and it uses an algorithm. This is algorithm, actually algorithm name Dijkstra algorithm, or you call it as shortest path first algorithm, SPF algorithm. And the metric for OSPF is cost. How you can calculate the cost? To calculate the cost, you can use the formula, that is 10 power 8 divided by bandwidth in bits per second of your interface. For example, if I have my serial interface, if I have my fast Ethernet, I want to calculate the same. So it's very simple. You put up 10 power 8 divided by bandwidth in bits per second and you will get the cost. So we will have the separate discussion on this, but make sure this is what the cost calculation is. It supports unlimited hop count. It supports unlimited hop count. Since if you remember in EIGRP, we discussed about it supports the hop count by default as 100 and maximum you can increase it to 255. But in OSPF it is unlimited hop count, no limits on this. And OSPF uses the multicast address 224.0.0.5 and 224.0.0.6. These two addresses we have, and these two addresses used by the OSPF to advertise the updates. So we will discuss why these two addresses and what is the use case of each. We will discuss in detail. OSPF also has the features of equal cost load balancing, where by default it can perform the load balancings for 4 path. Maximum it can go up to 16 path itself. Okay, so this is basically 16 path is in terms of old iOS. If you have the new iOS, in this you can perform the load balancing up to 32 path. Instead of 16 you can have the 32 if you have the new operating system of Cisco. Make sure. So these are couple of important points about the OSPF. When it comes to OSPF characteristics, some more points like how OSPF works actually. Make sure OSPF we need to configure between the routers, and by using the hello packet itself, OSPF is going to establish the neighborship and exchange the routing informations later on. That's what it discover the neighbor and establish the neighborship by using the hello packet, and the interval for your hello is about every 10 second and dead interval is 40 second. Dead interval is 40 second. So every 10 seconds routers will send the hello packet, and if a router is not receiving the hello from neighbor, it will wait up to 40 second hold down timer. That's what dead interval is. Next you have OSPF sends the update, and these updates contains the LSAs. Say for example, this is your update packet, OSPF update packet. So in this OSPF update packet, it contains the LSAs. And these LSAs are basically the detailed information about the router's interfaces. LSA is equal to link state advertisement, and it is basically the detailed information about the router's interfaces itself. Okay, see, the very simple LSA is link state, correct? Link is about the router's interface, and state is equal to descriptions of all the interfaces sending to neighbor routers, and this LSAs will be refreshed in every 30 minutes if there is no change. If there is no change in the topology, the LSA refresh will be in every 30 minutes. And when there is a change in one of the topology, immediately this LSA refresh will take place. Two conditions. If no change in the topology, every 30-second LSA will be refreshed. And if there is a change in the topology, immediately the LSA will be replaced between the routers. The administrative distance for OSPF is 110. 110. This is administrative distance for OSPF. For EIGRP, administrative distance is 90. Okay, make sure. So far, when it comes to OSPF, it maintains three different tables. So since we have already discussed in EIGRP that EIGRP maintains three tables, where the first one is neighbor table, then topology table, and then routing table. So this is what the three tables in EIGRP. When it comes to OSPF, OSPF maintains neighbor table. Same thing, it is all about, it contains the information about all type of OSPF neighbors. And database table is just similar to your topology table, where the database table contains the information about the entire view of the topology, with respect to each routers. Fine. Last but not the least, OSPF routers maintain the routing table. It is all about, it contains the information about the best path to reach the destination itself. So by using the database table, it will run the SPF algorithm, shortest path first algorithm, and calculate the best path and put that same path into the routing table. This will be the process here. How you can go ahead and configure the OSPF? It's very simple. IP routing is the recommended one, since we know that. Next we have to remember router OSPF and then process ID. Make sure this is your numbers, any numbers like 1, 2, 3, 4, some number you can define. Let's say process ID is 1. Router OSPF process ID is 1, and then router ID is very important to configure. This is again one of the important point. Router ID you can configure. Later on, you need to define network, then network ID, wildcard mask, just like EIGRP, network, network ID and wildcard mask. Later on, you need to add the same syntax with this additional points like area and area ID. Basically, OSPF works with area concept. OSPF works with area concept, where area 0 will be considered as backbone area, main area that has to be always present in your topology. So you can put up area and area is 0. Simple. You have configured the OSPF. What exactly these areas are? Just to understand a very basic point, see this. Say for example, when we are configuring the EIGRP between the router, say for example, this is my topology, and if I want to configure EIGRP here, so of course you need to go ahead and put up the AS number here. So AS number is 100 right now. I am putting between R1 and R2. That means we have created a logical boundary, and we are saying that this both the routers should go ahead and form the relationship and exchange the update as well. Correct? No? So this happens basically in terms of EIGRP, where in terms of OSPF, how it is going to work. In terms of OSPF, it is little different. It is like, let's say we have the same routers connected here, your R1 and R2. So right now you need to configure OSPF, let's say OSPF and OSPF. So make sure while configuring OSPF, we need to provide the process ID. OSPF process ID 1, OSPF process ID, let's say 1 or maybe 100. This OSPF process ID can be same, it can be different also, because this is just to identify the local OSPF process. Local OSPF process, make sure. So it can be same, it can be different also. Think about how you can provide the logical boundary here, because we want this OSPF router has to be in the logical boundary. This boundary will be defined basically by using the area concept, and where the area 0 must be present, which is called as backbone area. So in OSPF, area should match between the routers to form the neighborship. In EIGRP, AS number should match to form the neighborship itself. This is very, very important. So make sure in terms of OSPF, area ID should match between the routers to form the neighbor relationship. Process ID can be same, it can be different also. There is no impact of process ID here. Moving ahead. That's it. Next we have how to verify the protocols. It's all about show IP route, show IP protocols to know about the protocols, show IP OSPF neighbor to know the neighbor detail, show IP OSPF database to check the database table in detailed. So we will see this all commands in our lab itself so that it will be more clear to you. Now, last but not the least, we have the router ID to discuss. As we discuss, the router ID is basically the name of your router, you can say, name of the router. And it will be there in which format? In IP address format. Fine. So router ID is used to identify the routers in OSPF, and of course the preference is given as similar to EIGRP, like first preference given to router ID command. If you configure, it will take this first preference. Second preference, in case if you haven't configured, it will check the highest loopback IP address itself, which will become the router ID. If loopback is not configured, then it will check the highest physical IP address and it will make that as a router ID. How to configure this? Router ID, of course, this command is very easy. Under OSPF, you need to define router ID and router ID that you need to configure. That's it. This is what the router ID configurations. Now, this is what we have, some of the basic points that we have discussed, and that's it for this particular lecture, guys. We will see you in the next lecture with the demo. Thank you.